Hello everyone, you are welcome to Mathematics 2. This is the Cambridge Igcse Mathematics Paper 2 Variant 2.2 written in October-November 2024. There are 23 questions in this paper. If you are seeing this channel for the first time, please kindly subscribe to my YouTube channel by clicking the subscribe button. Also, like, comment and share this video. Let's jump into the first question. These are the first 8 terms of a sequence. C minus 3, minus 9, minus 15, minus 21, minus 27, minus 33, and K. Find the value of C and the value of K. So if you observe very well, you see that the term-to-term rule is add minus 6, add negative 6, okay? So because if you add negative 6 to negative 3, you get negative 9. If you add negative 6 to negative 9, you get negative 15, and so on and so forth. Okay, so for you to get C, then you have to subtract negative 3 from negative 6. Okay, that is minus 3 minus negative 6. Okay, so this will combine together to become positive. So that is minus 3 add 6, which is 3. So the value of C will be equals to 3. And the value of K will be minus 33 minus 6. So that will be minus 39. Okay, question 2. The diagram shows an isosceles triangle. Find the value of X. So this will be 43 degrees as well. So we know that the sum of angles in a triangle add up to 180 degrees. So we can say X add 43 add 43, so will be equals to 180 degrees. So these two add up to 86. So X add 86 equals to 180 degrees. Subtract 86 from both sides. Then X is equals to 94 degrees. So that will be the value of X, 94 degrees. Question 3. Complete each statement with a number from the list. So dash is a natural number. So a natural number will be this. So let's pick 24. Okay. So let's remove this. We're not asked to draw a ring. Okay. So dash is an irrational number. Okay, so root 3 is an irrational number. Okay, so let's pick root 3. Then dash is the reciprocal of 4. So reciprocal of 4 will be 1 out of 4. So 1 out of 4 is the same as 0.25. So put 0.25 here. So let's go to the next question. That is question 4. The scatter diagram shows the number of rooms and the number of people in each of 8 buildings. Okay, so you have the scatter diagram on the grid. One of the buildings has 67 rooms. So write down the number of people in this building. Okay, let's go to the grid. So 67 rooms will be this. Okay, so if you trace it down, the number of people will be 76. Okay, 70, 72, 74, 76. This particular one. Okay, so let's scroll down to be 76. Okay, so in part B, in another building, there are 42 people and 33 rooms. On the scatter diagram, plot this. So 42 people, 33 rooms. So 42 will be here. This is 42 against 33 rooms. Let's go. So this is 30, 32. So 33 will be the halfway. So if you trace this one, 42 against 30. This is 32, 33 will be halfway here. So it will be the middle here. So that's the spot or the point. Okay, see Roman figure 1 on the scatter diagram. Draw a line of bare feet. Okay, so the line of best fit will be the one that has almost equal number of points, okay, above and below it. Okay, so let's take this. If we take this one like this, let's take these two. Okay, I can adjust this very well. So I want to select these two. Okay, so it will be something like this. Okay, so I think and then I can also adjust this a little bit. Okay, good. So this is what line of best fit. So we have done that. The next question, there are 45 people in a different building. Okay, so find an estimate for the number of rooms in this building. Okay, so 45 people. So 45 people will be middle of this here. Okay, so if you trace it, it will be half here. Then if you trace it to the number of rooms, it should be middle here. So that is 29. Okay, according to our line of best fit. So it will be 29. So your answer might be different. Okay, it should be within a given range according to Cambridge Assessment International Education. Okay, so what type of correlation is shown in this scatter diagram? So let's observe the scatter diagram. So from the scatter diagram, you see that it's increasing. Okay, so along the x-axis it is increasing, and along the y-axis is also increasing. Okay, so this will be positive. Okay, so it will be positive. That will be positive correlation. So let's write positive here. Okay, so let's go to the next question. That would be question 5. Convert 7.51 squared meters into squared centimeters. So using this acronym, King Henry died by drinking chocolate milk. Okay, so this is the base where you have the meters. Okay, we also have the liters, and we have the grams. Okay, so we want to move from meters to centimeters, so that means we are moving from here to here. So 1 2, so you move 2 times. So but since this is for meters and centimeters, so for meter squared and centimeter squared, so you multiply the steps by 2, so that means you are moving 4 times. Okay, so you have 7.51, so you move 4 times towards this direction. So it will be 1 2 3 and 4. So the decimal point is here, so you fill up this with zeros, so that means you have 75100 squared centimeters. Question 6. The diagram shows a trapezium. The area of the trapezium is 42 squared centimeters. Calculate the value of x. So this is A, one parallel side, and this is B, the second parallel side, and this is H, the height. So the area is equals to A add B, the addition of the 2 parallel sides, multiplied by the height over 2. So if you key in the values here, so you see that 42 is equals to x plus 9.5 multiplied by the height, which is 6, then over 2. So you can say 2 here 1, 2 in 6 is 3. Then you can divide 42 by 3, that is 42 out of 3 equals to x plus 9.5. Okay, so this will give you 14 equals to x plus 9.5. So subtract 9.5 from both sides. Okay, so minus 9.5. Okay, so x will be equals to 4.5. So x will be equals to 4.5. Okay, that is centimeters. So we want to put centimeters here. So the next question will be question 7. Without using a calculator, work out this. So we have 2 out of 7. So we change the division sign to multiplication. And when that occurs, then you flip this fraction. 11 out of 6. 2 here, 1. 2 in 6, 3. So we're left with 1 by 11 over 7 by 3. So this will be 11 by 21. So that will be the final answer. So 11 out of 21. So let's go to the next question. The diagram shows a parallelogram. Work out the size of the smallest interior angle of the parallelogram. So you can see that this angle is equals to, the opposite angles are equal. Okay, that is one thing. Another property of the angles of parallelogram is that adjacent angles are supplementary, that is, they add up to 180 degrees. So this and this add up to 180 degrees. Of course, this and this should also add up to 180 degrees. Okay, so for that reason, we can say that 132 minus 2x plus 15 plus 5x equals to 180 degrees because they are supplementary angles. Okay, so we can add this and this together. That will give us 3x. Okay, then 132 plus 15. So this will give us 147. Then equals to 180 degrees. Then subtract 147 from both sides. Okay, then 3x equals to 33, and x will be equals to 33 over 3, which is equals to 11. So if x is equals to 11, okay, so that implies that this angle, okay, will be equals to, that will be 15 plus 5 into 11. So this will give us 70 degrees. So if this is 70 degrees, of course, this must surely be 110 degrees, as they are supplementary angles. So this will be 70, of course, this will be 70, and this will be 110. So the smallest angle will be 70 degrees. So let's go to the next question. That will be question 9. Point A, B, C, and D lie on a circle. A, B, C, D is a square with area of 72 square centimeters. Calculate the area of the circle. Give your answer in a multiple of pi. Okay, so let's say this is the center of the circle, center O. Okay, so we need to get the radius. Okay, so the radius will be from here to here. So we need to find the radius. So to get the radius, we can actually do something. Yes, we can find the diameter. Okay, we can find the diameter by using Pythagoras theorem. Okay, so this will be side L. This will be side L. So we know that the area of a square will be equals to L squared. Okay, so that means L squared is equals to 72 centimeter, okay, squared, okay, centimeter squared. So from here we can find dB. So dB will be equals to square root of, okay, square root of L squared, that is one side plus the other side. Okay, so this will be equals to square root of 72 plus 72. So this will be equals to square root of 144. So this will be equals to 12 centimeters. Now that we know dB, so we can get OB. Okay, so this is dB. Okay, so OB equals to dB over 2, which is equals to 12 over 2, which is equals to 6 centimeters. Okay, so now we can calculate the area of the circle. So area of the circle, so equals to pi r squared. So in this case, it will be pi into 6 squared, which is equals to 36 pi. So this will be the final answer, 36 pi. Question 10, let's scroll down. So input this, you can actually put this into your calculator straight away and put 1.4 here as the final answer. Question 11, factorize fully 24x squared minus 9xy. So we can factor out 3x, then we'll be left with 8x minus 3y. So this will be the final answer, 8x minus 3y. Part B, 63x squared minus 28y squared. So here we can factor out 7. If you factor out 7, so you have 9x squared minus 4y squared. So we can write this expression inside the parentheses as difference of two squares. Okay, so that will be equals to 7 into 9 is the same as 3 squared x squared minus 4 is the same as 2 squared, then y squared. So we can write this as 7 into 3x all squared minus 2y all squared. So we have difference of two squares. So that will be 7 into 3x minus 2y into 3x plus 2y. So it will be 7 into 3x minus 2y into 3x plus 2y. That will be the final answer. Question 12. Y is directly proportional to the square root of x plus 1. So that implies that y equals to k into x plus 1. So y is given as 10.5 and x is given as 8. So we can use this to find the value of k. So that will be, okay, let's make k the subject of the formula. So k will be equals to y over square root of x plus 1. So that will be equals to 10.5 over square root of x equals to 8, 8 plus 1. That will be 9, okay, 8 plus 1. So that will be into, okay, so that will be equals to 10.5 over, this add up to 9, so over 3, and, okay, we can leave the value of k like this. So find y when x equals to 1.56, okay, so let's substitute here. So y equals to k is 10.5 over 3, then into 1.56 add 1. So this will be equals to y equals to 10.5 over 3, then into 2.56. So if you input this into your calculator, you should get the value of y to be equals to 5.6. Okay, so let's go to the next question. That should be question 13. We have this grid. The region R satisfies these inequalities. So minus 3 is less than y. That is, y is greater than negative 3 and y is less than or equals to 2. So these are the two inequalities combined here. Then for this one, we have y less than or equals to x minus 1. So this will be a thick line, this will be a thick line, while this will be a broken line. Okay, so by drawing suitable straight lines and shading unwanted regions, find and label the region R. Okay, so let's start with this one here. Y is greater than minus 3. Okay, so y is greater than minus 3, so it will be here. So we can just use a broken line and draw straight here. So this will be for this. Okay, so the second one will be y is less than or equals to, okay, so I forgot to shade the unwanted. Okay, so y is greater than minus 3, so the unwanted one will be downward here. So we can just shade this one. So this will be unwanted here. Okay, the whole of this will be unwanted. Okay, I think I can take a better one. So we can do this now to finish it on top. So this will be the unwanted area. So let's take this like this. Okay, let's take this gently. Okay, so you need to shade all of this. This is the unwanted area here. Okay, so I'll just leave it like this. So the next one will be y is less than or equals to 2. So that will be a thick line. Okay, so y is equals to or less than 2. So you have from here like this. Okay, so it will be a thick line because of the equality sign there. So the unwanted one will be above this line. So let's carefully do this. So we need to take this. Okay, so we have to shade all of these and carefully do this as well. Okay, so this is the unwanted. So let's remove this. Okay, so that's the second one. Then the third one, okay, which should be the last one, is this: y is less than or equals to x minus 1. So let's draw y is equals to x minus 1, then we'll get this from there. Okay, so this is the general equation of a straight line. Y is equals to mx plus c. So c is equals to -1 and the gradient m equals to 1 out of 1. So let's go to -1 is here. So the first point is on this one. Then let's rise ones and run ones according to the gradient. So you have 1, 1. So you have another point here. So these 2 points are enough for you to draw this, but you can get as many as possible. Okay, so we can connect these together now. So let's scroll down. So this will be like this, like this, like this. So I can take it from here and like this. Okay, so let's scroll up a little bit. So it will be this. Okay, let's extend this line. It will be this. Okay, so we need to get the unwanted area. Okay, so is it above this line or below this line? Okay, so let's pick a point here, for instance. So if you pick this point, so let's say, okay, let's pick this one here. So x equals to -1 and y equals to -3. So let's see if it will meet this condition here. That is, it will meet this one. So y equals to -3. Then y is equals to -1. Okay, -1. Then let's see if it will meet this condition, less than or equals to x is equals to -3. Then -3, then -1. So we have -1 less than or equals to -4. So this is not true. -1 is not less than -4, and it's not equals to -4. Okay, so -1 is greater. So that means this region is the unwanted region for this. Okay, so this side will be y less than or equals to x minus 1. Why this is the unwanted region. So I will shade this one as well. So let's start from here once again. Gently, we take this. Okay, then let's take this. Okay, so carefully let's take this. Okay, so you can fill up this. Okay, so this is what we have. So the region R will be this. So this will be region R like this, and like this. So region R will be here. So you can just write region R here. Okay, so let's go to the next question. That will be question 14. Okay, question 14. You have this speed time graph. Okay, so draw the diagram shows the speed time graph for 17 seconds of a car journey. Find the acceleration of the car during the first 10 seconds. Okay, so the acceleration is from here to here. Okay, so we know that the acceleration equals to speed over time. Okay, so acceleration will be equals to the speed over time. So the speed is equals to 20 meters per second, as you can see here, and the time is 10. So you have 20 out of 10, which is 2 meters per second squared. No, sorry, I wrote in a different area. So it should be, the acceleration should be equals to speed over time, and that will be 20 over 10, and that will be 2 meters per second squared. So part B, calculate the total distance traveled by the car during the 17 seconds. Okay, so here you can find the area of this triangle and the area of this rectangle and add them together. So that is one way. So the other way is to find the area of this the whole shape, which is area of a trapezium. So if this is side A and the value is 17 minus 10, that will be 7. Okay, and then this from here to here will be side B. Okay, so that will be B is equals to 17, and the height is here. This will be equals to 20. Okay, so I can say that A is equals to 7. Okay, A is equals to 7, then B is equals to 17, then H is equals to 20. So using the formula, area is equals to A add B multiplied by H, everything divided by 2. This will be equals to 7 add 17 multiplied by 20, everything over 2. 2 here 1, 2 here 10, 7 add 17, 7 add 17, that will be 24 times 10. So the area is equals to 240 meters. So the total distance will be equals to 240 meters. So the total distance is the area covered under the graph. Okay, so let's go to the next question. That will be question 15. At the start of an experiment, there are 40,000 bacteria. So the number of bacteria increases at a rate of 15% per hour. Calculate the number of bacteria after 3 years. So this is exponential growth, and the formula is y equals to AB to the power of X. So y will be the new value, okay, new value, and A is the current value, which is 40,000. Then so B is equals to 1 plus R. So because it is growth, if it is the K, it will be 1 minus R. So which is equals to 1 plus R is 15%, which is 0.15, and is equals to 1.15. Okay, and X is the time, which is equals to 3. So therefore, so Y will be equals to 40,000 multiplied by B, which is 1.15 to the power of 3. So you can input this into your calculator straight away, and you have the value of Y to be equals to 60,835. So you have 60835. So let's go to the next question. That will be question 16. 75 people are asked if they have a car. That's C for car, and if they have a job, that is J. Okay, so the Venn diagram shows the results. A person is chosen at random from those who have a car, that is from this circle. Okay, so the total will be equals to 51 and 9. That will be 60, because this is the space, okay, where we want to pick. This is the space where we are selecting from. Okay, so find the probability that this person also has a job. So it has a car and also has a job. It will be 51. So the probability will be equals to, okay, so the probability will be equals to 51 over 60. So if you reduce this, okay, as 3 can go, so this will be 17 times and this will be 20 times. So we have 17 out of 20. Okay, so let's go to the next question. That will be question 17. Okay, so we have these A, B, and C are points on the circumference of a circle with center O. DA and DC are tangents to the circle. Angle ABC is equals to 64 degrees. Work out the value of X. Okay, so to get the value of X is inside this quadrilateral ADCO. So we know that this is 90 degrees. Okay, according to a theorem, the angle between the tangent and the radius is 90 degrees. So equally, we have 90 degrees here. Okay, so that means this angle and this angle are supplementary angles. They must add up to 180 degrees, as these two add up to 180 degrees. So this is angle at center. Okay, so it's twice angle at the circumference. So this will be equals to, okay, I think I can write something down. Okay, I can say 2 AOC. So angle AOC is equals to 2 into 64 degrees. So this will be equals to 128. So this place is 128. Okay, so that means the two angles 128 and X are supplementary. So I can say then X is equals to 180 minus 128 degrees. So X is equals to 52 degrees. So we have 52 degrees here. So let's go to the next question. That will be question 18. So this is the inverse set, 8 times 10 to the power of -1, which is the same as 0.8. So this is a recurring decimal. This is the same as 0.08. And this one, if you input this into your calculator, you should get 0.2828 for decimal places. Okay, so we have sets A and B respectively. So we have to complete the Venn diagram. Good. The element of set A, okay, A such that 0.08 is less than A, and A is less than or equals to 0.8. So that means 0.8 belongs to this, so you can put 0.8 here. And any number that is less than and 0.08 is less than a, so that means we need a number that is greater than 0.08. So which number is greater than 0.08 here? So we have this. So this one is greater than 0.08. Okay, so we can put square root of 0.08 here, and also this 0.8888 is also greater than 0.08, but it is out of this interval, so this cannot be here. Okay, so let's go for set B. Set B, the elements of set B are B, such that B is greater than or equals to 0.08. So 0.8 rather, 0.8 is also here. Okay, since 0.8 are common, so I can just remove this one here, remove this one here, and put it here because it's common to the two sets. Then another one that is greater than, another number that is greater than 0.8 is this recurring decimal, because this one means 0.88. Okay, sorry, I can write it here. This one means 0.8888 and so on and so forth. So I can just put 0.8 here. That's the recurring decimal. So this one belongs there, and this one belongs somewhere. This one belongs somewhere. So we are left with 8%. Oh, but let's write this one instead of writing 0.8. So we should have written 8 times 10 to the power of -1. Okay, for the 2. So this should be 8 times 10 to the power of -1. Okay, because that is how it is given from the question, not 0.8. Okay, this is just for you to get the picture. Okay, so we have 3 things here. So the last one, which is 8%, it does not belong to any of the 2 sets, so but it's part of the universal set. So we'll just put 8% outside the 2 circles, but inside the rectangle. So 8% will be anywhere here. Okay, so part B, shade the region A union C intersection B complement. Okay, so let's start with B complement. I think I have a series of videos on my YouTube channel regarding set and Venn diagram. So those videos are very interesting, so you can see those videos, okay, for you to understand this better if you are struggling with set and Venn diagram. Okay, so let's start with the complement. So the B complement means not here. Okay, regions or areas that are not in B. So areas that are not in circle, the whole of circle B will be outside the 3 circles, then part of circle A and part of circle C, but not in B. Okay, so we now need these parts that are not in B. Okay, so where they meet with A union C. So where they meet with A union C will be here, will be from here. Let's take this like this. Okay, sorry, but B is not there at all. Okay, so we can just take this. Okay, so let's do this completely. Okay, so let's remove the excess one. So we can remove this. Okay, good. Oh, sorry. Let's undo that. So this one here. Okay, so this is what you get here. So that is the shaded region. Okay, so the shaded region is A union C intersection B complement. So very simple if you see those videos on my YouTube channel. Okay, so question 19, we have this diagram, a solid is made from a cylinder and a hemisphere, both of radius 4.3 centimeters. The cylinder has length 11.9 centimeters, which is the height of the cylinder. Calculate the volume of the solid. So the volume of the solid will be, let's say, okay, the volume. Let's write here the volume. Sorry. So the volume of the solid will be, let's say, volume of the solid will be equals to volume of the hemisphere plus volume of the cylinder. Okay, so this will be, I think I can write this in full, cylinder. Then let's write this one. This will be hemisphere. Okay, hemisphere. Okay, so that will be the volume of the solid. Volume of the hemisphere, so that will be VH. So I think it's better to use the abbreviation. So it will be volume of the hemisphere will be equals to, this is volume of a sphere, so we need to divide it by 2. That will be the volume of hemisphere. So we have 2/3 by r cubed. So this will be equals to 2/3 times 3.142 times the radius is 4.3 cube. Okay, so no need to waste time. So this will be equals to 166.54 centimeters cube. Okay, so volume of the cylinder, okay, will be equals to base area times height. Base area is area of a circle by r squared times height. So this will be equals to 3.142 times 4.3 squared times the height, which is the length between the top and the bottom. Okay, that will be 11.9 centimeters. So this will be equals to 691.34. So the volume of the solid, so will be equals to 166.54 plus, let's write this very well, 0.54 plus 691.34. So this add up to, this is approximately 858, so 3 significant figures, 858 centimeter cube. So part B, calculate the total surface area of the solid. Okay, so the total surface area of the solid, so will be equals to the surface area of the hemisphere. Okay, so it will be surface area of the hemisphere. It will be surface area of the hemisphere plus the let's see, plus the curved surface area of the cylinder. So the curved surface area of the cylinder is 2. Okay, let's say curved surface area of the cylinder plus area of the circular top of the cylinder. Okay, so let's get this. So surface area of the hemisphere will be equals to surface area of the sphere is 4 pi r squared. So for the hemisphere it will be 2 pi r squared. So it will be equals to 2 pi r squared. So this will be equals to 2 times 3.142 times the radius remains 4.2, I think 4.3 squared. So if you do this, so if you insert this into your calculator, you should get 116.19 centimeter squared. Okay, so the curved surface area of the cylinder denoted by this is equals to 2 pi r h, that is the area of the circumference of the circle multiplied by the length, that is the height of the cylinder. So this will be equals to 2 times 3.142 times 4.3 times the length is 11.9. So this will give you 321.55 centimeters squared. Then the area of the circular top of the cylinder is equal to area of a circle, that is pi r squared. This will be 3.142 times 4.3 squared. So if you input this into your calculator, you should get 58.10 centimeter squared. So the total surface area will now be equals to, so therefore the total surface area of the solid will be equals to the addition of these three. So 116.19 add 321.55 add 58.10. So this is approximately 496 to 3 significant figures, 496. Okay, so that is pretty straightforward. So question 20, find an expression for the nth term of this sequence. So here you have 1 over 7, so you multiply by 7, you get 1, multiply by 7, you get 7, multiply by 7, you get 49, and so on and so forth. Okay, so but for this one to be 1, so that means you must have multiplied by 7, okay, then you now divide by, you multiply by, so for this to be 1 out of 7, so that means you divided by, let's say 49, okay, so if you have 7 now, let's say 7 divided by 49, so this will give us 1 out of 7, okay, which is correct. Okay, so the next one will be going to have, let's say, for this one to be 1, so the numerator and denominator must be the same. That means you should have 49 over 49. So what will make 7 to turn to 49 here? So that will be power of 2. So that means the nth term, so the nth term will be equals to 7 to the power of n, okay, to get this, over 7 to the power of 2, which is 49. Okay, so we can combine these two to have 7 to the power of n minus 2. Okay, so this will be the nth term, 7 to the power of n minus 2. So question 21, expand and simplify. So let's expand this. So this will be x add 3, okay, into 2x squared plus x, 5 times 2x, 10x. So that will be plus 11x straight away, plus 5 times 1, 5. So we can now expand this. So this will be equals to 2x cubed plus 11 x squared plus 5x plus, now let's multiply by 3. That will be 6x squared plus 33 plus 33, 33x, that's 33, okay, plus 3 times 5, 15. So this and this give us 17x squared. So you have 2x cubed plus 17x squared. Then this and this will give us 38x, then plus 15. So that will be the final answer. So we have 2x cubed plus 17x squared plus 38x plus 15. So let's go to the next question. This will be question 22. A is the point, this. So from here, it means x1 is equals to 17, then y1 is equals to 9. And B is the point, this. So it means x2 is equals to 23 and y2 is equals to 39. Find the equation of the perpendicular bisector of line AB. Give your answer in the form y equals to mx plus c. Okay, so we need to find the gradient of this perpendicular bisector of line AB. So this is line AB, for instance. So this is AB. So the perpendicular bisector will be like this. So we can call this C, and this should be the midpoint of AB. Okay, so the equation, the perpendicular bisector passes through the, let's say x, we have x1, x2. So let's say this is x3, y3. It passes through this point, and which is the midpoint. Okay, so we need to find the midpoint. So now, for us to get the gradient, so the gradient of AB, okay, so the gradient of AB, okay, multiplied by the gradient of MC, okay, so it should be equals to -1 because they are perpendicular. So once you know the gradient of AB, we'll get the gradient of MC. Okay, so here the gradient of AB will be equals to y2 minus y1 over x2 minus x1. So this will be equals to 39 minus 9 over 23 minus 17. So this will be equals to 30 over 6, which is equals to 5. So since we know the gradient of AB, then the gradient of MC, okay, will be equals to -1 over 5 straight away. Okay, then we need to find where the equation passes through. So that is x3 and y3. So we can say x1 is equals to x3 rather. So x3 will be equals to x1 plus x2 over 2. So this will be equals to 17 add 23 over 2. So this will be equals to 20 straight away. Then y3 will be equals to y1 plus y2 over 2. This will be equals to 39 plus 9 over 2, which is equals to 24 straight away. Now the equation will be y minus y3 equals to MC, okay, so into x minus x3 like this, okay. So y minus y3 is 24 equals to the gradient of line MC is -1 over 5 into x minus, then x3 is 20. So we can expand this. This will be y minus 24 equals to -1 over 5x. So minus times minus plus. So 1 over 5 times 20, that will be 4. Okay, so I can rearrange. So this will be equals to y equals to -1 over 5x plus 4 plus 24. Finally, y is equals to -1 over 5 plus 20, -1 over 5x plus 28. So -1 over 5x plus 28. So that is the equation of the perpendicular bisector of line AB. Okay, so let's go to the next question, which is the last question. The small box is mathematically similar to the large box. The volume of the large box is 72.8% greater than the volume of the small box. So from here, so we can say that the volume of the large box, denoted by this, is equals to 72% greater than the volume of the small box. So it will be, so we need to find 72.8% of the volume of the small box plus the volume of the small box. Okay, so because this will be the volume of the small box, okay, of the small box. So when you now find 72% of the volume of the small box, okay, and you add it to this, so that is when it will be 72% greater than this. Okay, so that is this is very important. So we can simplify this. Okay, 72% is the same as 0.728, okay, Vs plus Vs. So we can factor out Vs. So that would be 0.728 plus 1 into Vs, okay. So which I can write. So therefore, the volume of the larger box, okay, will be equals to 1.728 times the volume of the smaller box, okay. So now we can use a relationship, okay. So the small box has the length of 3.5 centimeters and the large box has a length of x centimeters, okay. So that means we can say length rather, okay, yes, we can say the volume of the small box is equals to Vs, okay, and the length of the large box will be equals to X. That's what we want to get. While the length of the small box is given as 3.5. Okay, so using the scale factor, so you can say the volume of the large box over this volume of the small box will be equals to the length of the large box cube over the length of the small box cube. So if you substitute the parameters there, so we have the volume of the large box, which is equals to 1.728 Vs over the volume of the small box, which is Vs, then it's equals to x to the power of 3 divided by 3.5 to the power of 3. So of course, Vs, we cancel Vs here. So we can now make x cubed the subject of the formula. So we can say x cubed equals to 1.728 multiplied by 3.5 cube. Okay, so we can take cube root of both sides, okay, straight away. So we'll be left with x here, which will be equals to cube root of 1.728 times 3.5 cube. So you can input this into your calculator straight away. So the value of x will be equals to 4.2 centimeters. So this will be 4.2 centimeters. Okay. So this is the end of my solution to the paper 2 variant 2. So in the next video, I will solve the variant 2-3. Until then, have your fingers crossed.